If you're a student, you definitely know the feeling. Staring at a textbook, wondering how all those words are supposed to turn into knowledge you can actually use on an exam. Well, how does that happen? In this explainer, we're going to decode the secret language your brain uses to turn raw information into real understanding.
So, here's our game plan. First, we're going to crack open your brain's internal code. Then, we'll dive into the three main ways it represents information. From there, we'll follow the journey of how a random thought becomes a permanent memory. We'll also compare your brain's mental workbench to its massive library. And finally, we'll see how you can use all this to get better at, well, pretty much anything. Let's jump in.
All right, let's start with that big question, the one every student faces. You spend all those hours reading, highlighting, making notes, but what's the actual magic trick that happens in your head that lets you pull out that information during a high-pressure exam? The answer to all of it comes down to one core concept: mental representation.
And that leads us right into our first section, understanding your brain's internal code. Think of these mental representations as the operating system your brain runs to make sense of literally everything.
To put it simply, a mental representation is an internal model of the world that lives inside your head. It's not the thing itself, right? It's a cognitive shortcut, a symbol that stands in for a person, a place, an idea. These are the absolute fundamental building blocks of how we think, reason, and remember.
But here's the cool part. Our brains aren't just one-trick ponies. They're actually multilingual. They use three really distinct formats or languages to code all the information coming in. So let's break them down.
First up, you've got propositional representations. Now, these are abstract, and they're all about language. They aren't pictures in your head. They're more like statements of fact. They capture the relationships between different concepts. This is the code your brain uses for things like logic and complex reasoning. For instance, if you hear the sentence, "The cat is on the mat," your brain doesn't actually have to create a picture of a cat. Instead, it can create a super efficient propositional code that just gets the facts. There's a cat, there's a mat, and the relationship between them is on. This is incredibly useful for processing all the abstract ideas you run into in your textbooks.
The second type is analogical. Now, these representations work by capturing some of the real physical characteristics of whatever they're representing. They're all about similarity, and they're a really powerful way we connect something new and abstract to something we already get.
You know, a perfect example is a mental map. When you're trying to figure out how to get to that new coffee shop, you're not just reciting a list of street names, are you? No, you're using an analogical representation, a map in your head that holds on to the real-world spatial info, like the turns, the distances, and where the big landmarks are. It's a tool you use all day, every day.
And third, we have mental images. This is probably what you first thought of. It's that representation of a sensory experience, what something looks like, sounds like, or even feels like, all playing out in your mind's eye.
Go ahead, try it right now. Can you picture the face of a close friend or the exact layout of your childhood bedroom? That detailed, almost photograph-like picture in your head, that is an incredibly powerful form of representation, and it's tied to some of our most vivid memories.
Okay, so we've covered the what, the three different ways our brain represents things. But how does information from the outside world actually get turned into one of these internal codes? That's the journey we're taking now, from our senses into long-term storage.
It all happens in three main stages. First is encoding. This is where your brain takes everything you see and hear and translates it into a format it can actually use. Then you've got storage, which is just holding on to that info. And finally, the all-important retrieval. That's when you access the information, like when a question pops up on an exam.
Now here's the key. Your brain doesn't just dump this information into a big pile. It's an expert organizer. It sorts information into what we call schemas, kind of like mental frameworks, and builds networks that link related ideas together. Think of it like a perfectly organized digital filing system. That structure is what makes finding a memory so incredibly fast.
So that brings us to where these representations actually live and do their work. We really need to understand the difference between two major memory systems, the brain's busy workshop and its enormous library.
To really see where these representations fit in, let's look at the whole memory system. Information flows from a super brief sensory memory into our active, conscious mind, which we'll call our working memory. From there, if it's important, it gets saved into our vast long-term memory. Let's really focus on the difference between those last two.
The big difference is all about what they do.
Think of your working memory like a mental workbench. It's where you're actively juggling and working with information for whatever you're doing right now. Your long-term memory, on the other hand, that's the huge library where knowledge is stored away, just waiting to be pulled off the shelf when you need it.
And inside that massive library, in your long-term memory, representations are all about deep meaning and connections. They're filed away neatly in those schemas and networks we talked about. This is where the core understanding of a concept you studied is kept, ready for you to access.
But on the workbench, in your working memory, it's all about action. Here, you use representations to actively solve problems. And to keep from getting overwhelmed, your brain cleverly groups info into chunks. It's exactly what you're doing when you solve a math problem in your head or try to follow a complicated argument.
Okay, so let's see how all this theory can become a real-world superpower. We're going to focus on just one of these types, mental imagery, to see just how powerful this stuff can be.
Now get this. Research from sports psychology has shown that vividly imagining yourself doing something fires up the exact same neural pathways as when you physically do it. Just let that sink in for a moment. To your brain, imagining something is almost the same as doing it. The possibilities here are just huge.
For example, in one case study, professional athletes who simply mentally rehearsed different game scenarios showed real, measurable improvement in their skills and their strategy. They weren't just daydreaming, they were using detailed mental representations to train their brains and bodies, proving this stuff has a direct impact on how we perform in the real world.
So let's bring this all back home. The big takeaway is this. Understanding your brain's internal code isn't just a cool piece of trivia. Knowing how your brain likes to handle different types of information, whether as facts, maps, or images, is a genuine superpower for learning more effectively.
And that leaves us with one last question for you to think about. Now that you know about these different representations, propositional, analogical, and images, how could you consciously use them to study smarter? Could you turn a dry list of historical dates into a vivid visual timeline in your mind? Or maybe create a mental map of a really complex scientific theory? How are you going to change the way you study?